Have you ever wondered how MRI separates fat from water to detect liver disease? That's the two-point Dixon technique. This MRI method is used to separate and analyze fat and water content within tissues. To perform this technique, we'll run a multi-echo gradient acquisition where two echoes are collected at different times after each radiofrequency excitation pulse. The system then combines these two signal states to generate two additional images, a fat and a water map. In total, we get 4 different image contrasts that lets us clearly visualize and assess fat distribution. This sequence goes by many different names depending on which vendor you use. Now, on a 1.5 Tesla system, we typically set our first echo time to be in phase at approximately 4.5 milliseconds. And the second echo time difference falls in an out of phase state at approximately 2.24 milliseconds. There are 2 critical parameters we need to optimize to acquire these effective echo times. The first one is bandwidth. A too short bandwidth leads to longer readouts and longer echo times, and this gives us suboptimal calculation of the effective echo time. The second parameter is the matrix size on the frequency or read direction. A too high matrix size also results in longer echo times. So to reach our desired echo times, we need to keep our bandwidth high and matrix low. But at the same time, we must make sure that our resolution and SNR remain good. Let's now save and run this sequence to assess the liver. Excellent. In our first images, we can see the out-of-phase and in-phase acquisition. These are very important for detecting microscopic fat within the liver. When fat and water protons exist together in the same voxel, their signal behavior differs between these two echo times. A signal drop on the out-of-phase image compared with the in-phase image indicates hepatic steatosis. Let's keep scrolling and find our second set of images. These are the fat map and the water map. Water-only images suppress fat signal entirely, which improves visualization of liver tissue, focal lesions, edema, and inflammation. It also helps detect tumors, cysts, and diffuse liver disease. Fat-only images, in contrast, isolate and measure fat distribution. This helps us differentiate fat-containing lesions, assess hepatic steatosis severity, and identify focal fatty infiltration or sparring patterns. Together, these Dixon image sets provide a powerful non-invasive method to evaluate fat content, liver structure, and disease characterization.